Okay, whatever your prediction is, write it down. Because is there anything more satisfying than figuring out that you were right? Yeah. It's kind of like a puzzle. So if you're good at pattern recognition, puzzles, this is the kind of thing you could be good at. So in a biopsy, they take a needle, a really long, very skinny needle. They go in, they take trace amounts of cells from multiple locations to kind of tell us how far, if there is a tumor or cancer, how far has it spread. All right. We kind of covered this already, but let's think, now that we know more about epithelia, why are they more prone to becoming cancerous? Daniel.
Die and regenerate so often. It's not, is regenerate the right word?
Yes. So they're going to replace themselves more often. They have a higher regeneration rate. Yes. What else? Think about where they're located. Amelia? Yes, so externally we're exposed to radiation from like UV lights. What about internally? Where do we see them? And what are some things that our inner linings might be exposed to? Sure, we could have pathogenic. There is pathogenic cancers that are caused by viruses. What else? Yeah, if you're smoking, you're exposing the entire inner lining of your respiratory tract. Your digestive system might be exposed to certain carcinogens that are in foods. So yeah, all of these cancers that are derivative of epithelial tissue are called carcinomas. This will be our focus for today. There are other types of cancers, sarcomas, leukemias, lymphomas. They're different tissue types each time. But carcinomas, these are all epithelial-based cancers. 80 to 90% of all cancers are going to be carcinomas. So, just like we said, we're going to relist them here. Carcinogens, these are toxins, chemicals, maybe even pathogens that are going to potentially cause DNA damage. So, our cells, those are the ones that are going to be more exposed to those carcinogens. As we said, skin to UV rays, maybe the lining of the digestive tract to certain foods, certain red meats or charred foods, and then the inner lining of the respiratory tract to smoke or other pollutants that we're inhaling. There is one more thing we didn't cover. Yeah. So certain meats can be carcinogenic. So like highly nitrogen, nitrates. So lunch meats can cause certain digestive tract cancers. Consuming too much red meat can cause it. They're linking it, right? We don't know for sure. We can't test it. We can't expose someone to it, but we can do data studies. Yeah. So think about the difference between epithelial cells and connective. Epithelial cells, connective. Interpret my dance. Where are the cells?
Epithelial is like the first,
No, that's true. That's true. We've covered this. Yes, they are touching each other. So, epithelial cells are way more densely packed. So, certain signals can be overruled. We can form a tumor much faster because they're so closely packed together. Whereas connective, blood, they're more spread out. So we have that higher rate of cell regeneration, as we mentioned. And yeah, they're more densely packed. So these are the three reasons why carcinomas are way more common than other types of cancer. Yeah. could be depending on what stage it's in. Yeah, so that's what we'll be talking about. So if you catch it in stage 0 or 1, we can potentially remove it with surgery. Because yeah, connective tissue is sometimes a lot deeper, harder to get to. All right. Here is some key terminology that I will be discussing. Parenchyma. In this case, parenchyma is going to be your epithelial tissue. But in general, it's always going to be the functional part of the organ. So since we'll be discussing carcinomas, yes, your parenchyma is going to be that layer of epithelia. And that's where these things are going to originate, in those layers. So an example, simple columnar epithelia of the stomach. The function of it is it's secreting mucus and enzymes. That's why it's considered the functional layer, or parenchyma. Okay? Stroma is the supportive tissue of the organ. In this case, it's going to be the connective tissue parts. Sometimes it's muscle, sometimes both of these things are connected, but for our example today, it's going to be the connective tissue layer. So our example is that dense, fibrous, irregular tissue of the skin that supports like the epidermis. You do not need to write down the examples. I'm just describing them for you. But these two, depending on where these cells are found, either if they're still in the parenchyma or if they're found in the stroma, that's going to tell us what stage we are in. Okay. So again, epithelia up here. Oh, it's not showing up. That's our parenchyma. Remember that epithelia have that basement layer. That's really important. And then everything underneath is going to be considered the stroma. Cool? Parenchyma, basement layer that separates it, stroma. All right, here we go. From benign growth to metastatic cancer, how do we get there? First thing that's going to typically happen is hyperproliferation. The cells are going to replicate at a higher rate. Remember, this is the parenchyma layer, the functional layer. So a tumor or mass will form. If you see the word tumor, tumor does not necessarily mean cancer. It just means a mass of cells. We would consider this stage, if it's just hyperproliferating in the parenchyma, we would consider it benign because it's still contained in its original tissue. We could pick this up with, say, an ultrasound, maybe even like a CT scan or an X-ray. And the good thing is, this would be stage 0 or 1. So if you know someone who has been diagnosed with stage 0 or 1, that's a really, really good sign. Technically, depending on what organ we're looking at, that would not be considered cancerous. It's still considered just a benign tumor. It might have the potential to get further in the stages, but at this point, if we catch it here, it's a great sign. Timo, what is happening over here? Okay. I feel like paparazzi. It took like 20. Yes. You can, and we'll talk about the risks associated with that tomorrow after our quiz. But yes, typically this is going to be a surgical removal. What are some things that causes hyperproliferation? Hopefully you remember some of this from maybe regular bio, AP.
So in mitosis, the checkpoints are functioning correctly?
Yes. Do we remember the protein? It's a letter and a number. It's the coolest protein. It's the one that actually does the checks. Yes. So there's a lot of ways that these mutations can happen. Maybe the gene for P53 gets mutated. So that bouncer at the door that's supposed to prevent you from coming in, if you didn't replicate properly, it went on a break. So your cells with this DNA damage just keeps replicating. That could be something. There could be enough damage that, I don't know, P53 doesn't detect it. There's all kinds of things. But the main thing here is P53 is not doing its job. So it's letting damaged DNA continue to proliferate into other cells. Usually, too, there's something called contact inhibition. It's not written there. But contact inhibition is when cells will touch each other and they're like, okay, hi friends, we can stop dividing. We've closed the space. If they ignore that signal, they'll keep dividing upward or out, and that's how a tumor can form. So they're ignoring those contact inhibition signals. Okay, so that's stage 0 or stage 1. Now we're going to get into invasion. Oh my goodness. Yes. So what are we invading? We're invading that basement layer. Oh crap. We have acquired a mutation that allows us to release certain enzymes to break through that basement layer. We're now invading the stroma. So remember, the stroma is that supporting tissue. So if we see cells going down into the stroma, into the connective tissue, we know we're at least in the next stage. We call this malignant. So now we're in a cancer classification. So here are 2 examples of a tumor that has invaded into the stroma. And you can see with this arrow, those are the 2 places where the basement membrane should be, but this tumor is secreting proteases to break through it. It's dissolving that basement layer so that it can break through. So we would call this stage 2. Yes?
So it's not like that going through the basement, they're just getting rid of
They're dissolving it so that when they can continue to replicate downward. Because what do we have in connective tissue that we don't have in epithelial tissue? Darren? Yes! These tumors are like, I'm hungry. I'm gonna go and find your blood supply. So in order to get to the blood supply, it's gotta get into the stroma. Yeah, so that's gonna be our next step, getting more blood supply. Cool, stage 2, malignancy. Now, stage 3, this is insane that this happens. Angiogenesis. We're literally sending signals to create more blood vessels. It is wild. So, this is another mutation the cells might acquire. They might not, but if they do, they're going to send out growth signals to blood and lymph vessels. Because since they're replicating at a higher rate, they need a constant supply of glucose in order to do that. This is another reason why a lot of people at this stage of cancer lose weight. That's sometimes a warning sign because the cancerous cells are needing energy. Quickly. Okay, yes, Amelia.
So like, if a person has really high levels of glucose, would that be a sign he has no?
So it's not high levels of glucose necessarily, but what I'm going to show you a way that we detect it. If we we use glucose and we put a fluorescent tracer on it. If it glows super bright in an area, then we know that's a tumor that's taking in a ton of glucose. So that's how we can tell. So I'll show you that in a moment. It's called a PET scan. So at this point, now we have the potential to travel. So not only do we have this amazing blood supply, all this blood and sugar and oxygen just for me, but now it can get into the blood supply and travel. So we call this metastasis at this point. And this is stage 3 if it's local. When we say local, we're looking at the nearby lymph nodes. Yes?
What exactly is now able to travel?
Cells. Cells can literally break off from the tumor and get into the blood supply. So that's a risk of surgery. Going back to your question. If we surgically remove it, we're cutting into things, we're cutting into blood. Cells, remote cells can get into the blood supply. So that's a risk. Yeah.
So if somebody has like cancer, like why would they like to remove somebody's leg or arm or something if they have cancer? Would it be like
Perhaps. I'm not sure if that would necessarily be from an epithelial drive. That might be more of a sarcoma, where the bone or the muscle has a big enough tumor that it's affecting the overall function.
and how would you stop cancer from like
Hopefully you catch it early enough. Then you don't. Then it could. So this, we might not ever get to this stage. You might have cells that never acquire this mutation. So it gets to stage 2 and it stops. Or you might get all the way to stage 4. Every single stage needs a different mutation for it to occur. Yeah.
Let me back to that, see if I can clarify actually the last one.
Oh, that's fine. Write it down. Yeah. Okay. So nearby lymph nodes. Yeah, go ahead.
Is that why, like, during chemotherapy, it attacks your collagen and the tissues, and that's why you super?
So it actually attacks the cell. So all of your hair has a bit of those cube cells around it. So it's actually killing the cube cells that make the hair, and that's why it falls out. Yeah. So that's a great preview in the future. Chemo kills all fast-moving cells. So because it wants to target cancerous cells. So anything, literally all your epithelia. That's why you lose your hair. You feel really sick to your stomach because the inner lining is getting messed up. Yeah. That is only keratin. So I guess your nails could fall out. Yeah. Okay. Right. It's a similar type of process as your hair creation, I would think. Yeah. Oh wow. Yeah.
Do the chemo and the radiation cause different symptoms?
Yes. So again, we're kind of skipping ahead. That's fine. That's totally fine. Radiation is a targeted beam to try to induce apoptosis. Chemo is something that goes into your bloodstream and travels all over. So usually when people are really sick, vomiting, losing their hair, it's chemo related. So radiation would be a different therapy.
How do you know when to use radiation?
Love this. Okay, so usually they will radiate if it's a stage 2. If you're at stage 3 or 4, they might radiate the main tumor and then give you chemo to look for any other rogue cells that have gone around the body. They should not give you chemo if you're at stage 0 or 1. They shouldn't. They could do targeted radiation. So that's one of those things that you want to get multiple, references or whatever, opinions, exactly. Yeah. Because there's risks with all these things. So if you're using it way earlier than you need to, it could cause more symptoms. Yeah? Okay. So here's an example of local lymph nodes. If you have some kind of tumor in your breast, and then we've got lymph nodes in our armpit or axillary area, if we see a collection of cells there, we know it's metastatic. Okay? Now, step 4, immune evasion. So we do have some immune cells that can go and find these rogue cells that are traveling around your bloodstream. But sometimes even your rogue cells can get a mutation that make them like invisible. And that's this last step, immune evasion. If this happens, that means that they have the ability to travel way far in the body. And this would be distant metastasis. Maybe they're going to set up shop even like in a whole new organ. So you have something like a melanoma, which is a derivative of your skin, your melanocytes, and then they travel and deposit into your lung or your brain. So we call these secondary locations. You could have a tertiary tumor like at a third site. And at this point we are in stage 4. Yeah.
How would you figure out what exactly happens each stage?
So for stages 1 and 2, we would do that needle biopsy. If we see that we're in stage 2, we would go further because we can't tell if we're in stage 3 or 4 just from a needle biopsy because that's just a little snapshot.
No, I mean like how do we know that in stage 4 you acquired, like how do we figure out what happens?
Cellular biology research. We look at the genes, we look and see what genes are turned on or off. We see what receptors on the cell surface we're missing or have, and that's how. That's all this research that we're doing. We're looking at what's happening to the cells. So to detect this, stages 3 and 4, we would use a PET scan. So PET, I realize it's not on this, stands for positron emission topography. So this kind of goes back to the question Amelia had before about like, well, can we use glucose to figure out where these things are? So we attach a little fluorescent ion to a glucose molecule. That molecule is called FDG. And you would take the molecule into your body, either like orally or it would be injected in. The FDG is going to go and travel and be taken in by cells that are going to need it the most. So we're going to see high levels of FDG intake if we have a tumor. So the good thing is we put you in this thing where the FDG will go and collect and they're going to emit positrons. The machine picks up where those positrons are and it glows. So this can tell you where there is a collection of cells that are replicating at a very high rate because of how much glucose it's taking in. So we can assume these are all either tumors or lymph nodes where there is cancerous cells that have collected. So that's a PET scan. So without a PET scan, we really can't tell what if you're in stage 3 or 4. We need that as like a secondary thing to do after the biopsy is done. If we can tell by the biopsy that we're definitely only in stage 0 or 1, we likely would not need to do this next step. Okay? All right, so let's put all of this information, I'm gonna skip this for a moment, to do a little sorting review. You're gonna get a set of descriptions and pictures, and you're gonna put them in order. And it's not necessarily gonna be 2 descriptions per picture, just keep that in mind. Work with your pair.